Hi, this is Diana from Droid's newsletter. I'm here with Ed Mehr from Machina Labs. Your company is more of a physical AI company than a traditional manufacturing company.
Great. Thank you for having me. Uh, no, excited to be here. We at Machina became well known for our process around sheet forming. We have a specific embodiment. We call it roboforming. So people know us with that because it's a very catchy process. It's almost mesmerizes you. You start from a flat sheet and deform it into shape. But the platform is a multi-purpose, general purpose manufacturing platform. We call it Robo Craftsman because it's very much operates like a craftsman does. Our goal is to create a platform that can make car parts in the morning, but then in the afternoon, without any physical change, it can start doing aircrafts. And at night, autonomously, it can do missile components. So what we're trying to do is really break away from traditional paradigm of manufacturing, which is very custom built factories. And what that means is that you can go from a design intent to product, to a physical product in the real world much faster and much cheaper than you traditionally could.
What I'm hearing from you is that you're not trying to replace traditional manufacturing, but you have come up basically with something new.
Yeah. And if you see most of our customers, they're doing something new with this, right? So Toyota, great manufacturer. They know traditional manufacturing very well to the point that in the US, they make one cars every 60 seconds. What traditional manufacturing cannot do is make a different car every 60 seconds, make a unique car every 60 seconds. And that's where we come in. In this case with Toyota, we're complementing traditional manufacturing where they're really good at the volume and we're really good at customization. A part goes through a traditional manufacturing and we make customizations to it so that everybody can drive a very expressive vehicle. The tailgate is customized to represent the design that you want. The hood is customized to represent the design that you want. Now we can get this customizability, which is a completely new product category, a new profit center for Toyota. And this is what a lot of our customers are doing with us.
This vision you give for a factory, do you see this now as like the factory of the future?
Today, if you walk around, there's not a whole lot of design variety. All cars kind of look the same within their class. Every building kind of like built the same way. And that's actually a limitation of manufacturing because we only can scale and make cheap stuff today if you're making the same thing over and over again. I think the next generation of factories, or what we call factories of future, will break that paradigm. Will be a paradigm where you don't need to make the same thing over and over to be cost effective. You can actually have very high mix and high variety, but still achieve scale.
Now, when I've heard you talk about these factories before in some of your other interviews, you were talking about a changing role for blue collar workers.
I think it was like a few years in the making. I'll call it teal collar worker. They're mixing. Blue collar is becoming white collar, and white collar is almost being forced into becoming a little bit more engaged physically. And we see this already happening in our shop floors. I think with AI now, we are going to be a little bit more multidisciplinary, right? I think people are going to be both physical and intellectual. They're going to be both blue collar and white collar. And we are start seeing this in our factories where the same manufacturing engineers, the same people who are operating robots, the same engineers who are designing it, they're using AI, then they're white collar for half of their job, but then they're also blue collar for half of their job. Down there on the floor working on physical things. AI is going to be extension of our brain. Robotics is going to be extension of our muscles. And we're going to have this more hybrid paradigm now for us is not necessarily just to specialize, where we still need specializations in a few areas, but the predominant portion of our workforce are people who are a little bit jack of all trades.
You had an experience at SpaceX that really kind of inspired you to come where you are now.
One day, I got a chance to go see SpaceX factory. And initially I didn't believe it. I was like, hey, they're actually building rockets. I was like kid in a candy shop seeing all that happen. But the moment I joined, I saw this fundamental challenge and realized why hardware space has been moving much slower than the software space. And really the limitation was manufacturing and fabrication technologies. Because you have to go build this custom factory every time. Even a company like a SpaceX who moves really fast. In a span of 25, 26 years that they existed, they have only two launch vehicle families. It's the Starship family and the Falcon family and they're built out of two different facilities, two different sets of technologies because of this limitation where factories are very custom built. My focus has been on bringing this agility back, bringing software-like agility to manufacturing. That was my journey, really kind of bringing that speed to manufacturing and seeing the challenge at SpaceX. Now, I think defense is one of our major first adopters because that's where they need a lot of agility. They want to make 50, 60, 70 different weapon systems, and they're all going to be low volume, high design variety because they need it for different types of missions. So we announced, for example, one of our major partnerships has been with Lockheed Martin, where we're qualifying and going to production for JASSM fuel tanks. It's a air-to-surface missile that also significantly was depleted. So we're working with Lockheed to manufacture these tanks and replenish this supply chain, but also significantly increase our rate. So bring this capacity online for producing these really critical defense systems that we need.
When you're talking about these mission critical parts, like you'd mentioned earlier about putting a part on a plane like a C-17, if you're taking metal and you're bending it back and forth, like I imagine a paper clip being bent back and forth, eventually that paper clip's going to break. So what is it about your roboforming process that allows that to be strong enough that these parts can be so mission critical and be used in these kinds of applications?
The process you're describing is called fatigue. As you basically work the material, it becomes harder, sometimes more brittle, depending on the alloy system. We're not constantly going back and forth. We're slowly deforming it. We apply compressive stress. So those two robots, we're not just bending it like this. We're applying compression from both sides that allows you to delay the fracture, but still achieve the goal, which is give it a shape. There's a lot of local process parameter optimization that we can do through, for example, this compressive stress. At the end of the day, one of the beauty of our process is we are almost doing it the same way it was done almost 100 years ago. That's why we call it robo-craftsman. It's almost the way craftsmen did it a while back, but now robots are doing it.
So if we were to have this technology, let's say a year from now, and then we spoke again 3 years from now or 5 years from now, what would we be talking about?
I think these robo-craftsman cells, we're going to keep learning new skills. You look at some of those humanoid companies and they're teaching robots how to do what I call 5-year-old physics, balancing things walking around. We're teaching our robots to do trades, sheet forming being one, bending, hemming another, welding and assembly another. So you will see the same robotic system not only does forming of the sheet metal parts, but does all these other operations. And when a robot can do multiple operations, then you can easily scale it in a facility. So you're going to see more facilities like the one we're going to announce in Q4. You're going to see more facilities around the world in the US and our allied economies. These are smaller, 200,000 square foot facilities where you're going to have group of these systems deployed, and they're completely programmable factories. One factory might be doing automotive components, another factory might be doing stuff for energy sector. And the robots are programmed to do these operations just through software. There's going to be a software portal that allows engineers to connect to, submit their designs, get guided through how they can make it manufacturable using our RoboCraftsman, and then submit it to that portal, and the right factory in the right location gets programmed to do those parts and ship those parts components to them. The most efficient way and the fastest way compared to traditional technology.
I have one last question about the coolest thing you've ever made.
Sure.
And I'll just tell you that I have my stormtrooper helmets in the background there that I usually move for the interviews, but I put them all back there.
It's kind of funny. You have also a Saturn V vehicle. I had a Saturn V vehicle like that, the Lego Saturn V, since my 6 days. I've carried it through 3 companies. Good taste.
Thank you.
The coolest thing, if you come to our facility number 2, right at the entrance, there is Han Solo frozen in carbonite. There's formed Han Solo in it. So, and it's pretty large. It's like a 14-foot. So it's a little bit daunting.
Amazing. I'll come in my stormtrooper costume for that.
I love that.